There we go. Okay, so let's talk about how to name angles, because you do have to be careful. You've already seen that geometry uses a ton of symbols, and angles are no different. You're going to use a lot of symbols when you're talking about angles. And I need to make sure that you understand what I'm talking about when I throw a symbol out at you, and I need to make sure that you use the correct symbols when you're communicating back to me to really say what you're trying to say. So if you look at this angle here, anyone know how to name that angle? Jackson?
An acute angle?
Okay, that's how you would classify it. How would I name it, Caitlin?
Angle PQR.
Okay, so I could certainly call this angle PQR. Anyone know another way I could name it? Franklin.
Angle RQP.
Okay, angle RQP. That would work. What about angle... I am aware. Thank you. What about angle QPR? Would that be okay?
No.
Why not? Rachel.
Because you're starting in the middle, so you have to backtrack to go together.
Okay, if I said angle QPR, you're literally tracing in that order. So you would go Q, and then to P, and then to R. And you see that that corner is not really the angle that you were talking about a minute ago. So that would not be okay. Notice how these both have Q in the middle of them. That's because Q is the vertex of your angle, meaning it's like that corner. Okay? Let's see if this will let me erase. Yes, it will. Good. There's one other way I could name this angle. Jackson?
Angle Q.
Okay. This one, because it's just a nice, simple, single angle, I could just say angle Q, which again, you're naming by the vertex. All right, so 3 different ways to name that same angle. But I want to make sure that you could look at that angle and name it like I did. Questions on that one? Okay, so what's the problem if I'm trying to name this angle here? Can I name it angle Q or angle just a single letter this time?
No.
Caitlin, what do you think?
No, because they're, like, B is connected to all the other angles that are in there.
Exactly. So angle B, which is the vertex of the angle I'm looking for, that's the vertex of all of these angles. So if I just say angle B, I don't know which one you're talking about. Okay? So how would I name that angle listed, or the one with the arrow there? Let me get a different color real quick. Hold on. That should work. Okay, Jackson, how would I name that one?
DBE.
Okay, I could call it DBE. What else could I call it? Abby?
Angle EBD.
EBD. Notice both times the B stayed in the middle. Okay, so you always want the vertex, whatever letter is at the corner, to be in the middle when you're naming that angle. Good. And then again, I could not just call it angle B, because this is a more complex picture that has more than one angle. So if there's a possibility, if you name it with a single letter, if there's a possibility of it being multiple angles, you can't just use a single letter, you'll have to use all 3. Now, mathematicians don't like to write, okay? They don't like to write stuff down. They want to make things as short and simple as possible. So sometimes 3 letters is kind of a stretch, all right? And so sometimes what you'll see also is what you see down here in this bottom picture, where they just kind of put numbers in the corners. And then you're allowed to just say angle 1 and angle 2. So like you could name it angle 1, angle 2. Obviously that's 2 different angles. Angle 1 would be this guy, angle 2 would be this guy. What if you wanted to name this whole angle though? Franklin?
Angle BAC.
Right, then you would have to go for the letters. So then you would have to say something like angle BAC if you were talking about the whole thing. But sometimes we name angles with numbers. Now those are not degree measures. That's not like 1 degree and 2 degrees. That's just like naming the angle. Okay? Does that make sense? Anything earth-shattering there? No? Good. Okay, so let's talk about bisectors, and you're probably going to want to write that down. I don't think I left that in there for you. An angle bisector is a line, a ray, or a segment that divides an angle into 2 congruent parts. Okay? And this right here is important, that the parts are congruent. So remember we've talked about bisectors in general. In general, a bisector is something that cuts something else in half. Okay? That's exactly what an angle bisector does, is it cuts an angle in half. So this line comes through the vertex of the angle and cuts it into two congruent pieces. So I would know this angle and this angle are equal to each other. Okay? If I told you the measure of this angle was 32 degrees, what would be the measure of this angle up here? 32 degrees. What would be the measure of the whole angle?
64.
Good, 64. Good. Everyone got that definition copied? Yeah, good. Okay, so here's an example of the type of problem you might see in your homework tonight. In the figure at the left, AB, and that should be ray AB. Sorry, I forgot to go back and put the symbols in there. Ray AB bisects angle CAD. And then it tells me the measure of angle CAB. So again, this is making sure you know how to read your angles. Angle CAB would be this one, this top one. Everyone see where I'm getting that from? Okay. CAB is 5x minus 11. So I'm going to go ahead and just write in here that this is 5x minus 11. And what's my other one? BAD is 2x plus 25. So BAD, that's this one down here. Was it 2x minus 25? 2x plus 25. Thank you. Okay. And then it says find the measure of angle CAD. So that's once the measure of the whole thing. Well, we know we're going to have to add these two together, right? But we want an actual measure here. We don't want like something x plus something. Okay, because I know some of you are already thinking like, well, wouldn't that just be 7x plus 14? Because you would combine this and combine this. You're right. You are right. But we can find what x is and then get an actual number. Thoughts about how I can figure out what x is? Anyone have a thought? Jake?
Never mind. Right when you called me, I was thinking, never mind.
Oh, no.
Never mind.
Bertha?
X equals 7.
How,
2.
how would you get that?
Because you do 5x minus 11 equals 2x plus 25.
Yep, that's what I was looking for. Perfect. Yes, if we know that this is a bisector, we know that these two pieces have to be equal to each other, right? So I'm going to set up an equation. Actually, I'm going to shrink this down so you can see it. I'm going to set up an equation and say I know that 5x minus 11 would have to equal 2x plus 25. Everyone see where I'm getting that from? And now we have to solve it. What are your thoughts on solving this? Jackson, go ahead.
Add 11 to each side.
Okay, we could start by adding 11 to each side. So 5x equals 2x plus 36. Brooklyn, I don't know if your answer was right.
Yeah, I did it wrong.
Okay, but you had the right idea. That's what I was looking for. What do I do next? Caitlin?
Subtract 2x from 10.
Okay, let's subtract 2x. So I get 3x equals 36. Okay, back to this. What am I doing now? Abby, sorry.
36 divided by 3.
There you go. Divide by 3. And we get x equals 12, which is awesome. But does that answer our question?
No.
Our question was the measure of angle CAD. Hunter, what do you think?
You put 12 into 5x minus 11.
Okay. So back up here, now I know that x equals 12. So I am going to do 5 times 12 minus 11. What do I get, Matt?
49.
I think 49. And then same thing here, I'm going to do 2 times 12 plus 25. 24. So that's also going to be 49.
Well, also, can't you just know that it's 49 too because they're both
Yes. Yeah, great point. I was actually just going to say that same thing. They should both be equal. Now, this is, though, a really nice way to check and make sure you did it right, is if you plug this number in and you get a different answer down here than you did up here, then something's wrong somewhere. So I suggest you plug it in both places, but yes, you should know that once you find one of them, the other one should be exactly the same. So now, what's my total angle measure?
98.
98, good, because you would do 49 and 49 and get 98. Let me go back over here, and we would say 49 plus 49 equals 98 degrees, and that would be your answer. Which I think is a perfect segue to the next thing we're going to talk about, because take a look at that angle.
It's not 9.
Doesn't look like 98 degrees, does it, Franklin?
Are we gonna have to show like all the work?
You should show, I mean, you could probably skip a couple of steps in here, but I should at least see that this is how you started. I should see somewhere where you plug the 12 back in, and then I should see how you got your answer. So you wouldn't necessarily have to show all of that, but I would want to see some of it. Okay, so again, I want to point out what Matt just pointed out. This is not a 98-degree angle, okay, when you look at it in the picture. So let's talk about the rules of the road. Making assumptions from drawings. This is why they let me teach geometry, okay? Because you can't always tell from a drawing what is really going on in the picture. Okay, there's some things that you're allowed to look at a picture and assume, and some things that you're not. So, for example, by the way, do you remember what that word means? Collinear?
No.
Okay, something about a line, right? You see line in there. What does co mean? Rachel?
Oh, it was like a whole bunch of points together on one line.
Okay, so collinearity, you're right, is points that are all on the same line. So if the points are actually drawn on a line, okay, if you've got the points drawn, and there's a line going through them, and hopefully a line that's better than the one I just drew. We'll just make my points bigger. It's always my go-to. I can assume those points lie in a straight line because they're drawn on a line. But look over here. You can't assume collinearity if they're not drawn on a line. So if I just draw 3 points like this, you cannot assume that those are in a straight line unless I actually have a line drawn for you. Does that make sense? Okay? So if I draw them on a line, even if they look crooked like mine do, you have to assume they're on a straight line together if I draw the line. If I don't draw the line, you can't assume that. If 2 lines intersect, you can assume that, hey, these lines intersect right there at that point. Okay? Points in the interior, exterior of angles. Here's what that's talking about. If you have an angle, you can assume that this point is inside the angle. You can assume that this point is outside of the angle. So you can assume whether things are on the inside or outside of things. And anything marked, and again, this is why I keep my job right here, okay? Because if I draw something like this, and then I mark it like this, what do you have to assume? You have to assume it's 90 degrees, even if it is very clearly not,
I did that.
okay? When we start talking about regular polygons, that's when it gets really bad. I'm just going to be honest with you. Regular polygons are polygons where all the sides are the same length. So I'm going to be drawing you pictures on the board and telling you, hey, this is a regular polygon, and I'm going to mark them all congruent. They are not going to be congruent. But if I mark them as congruent, you have to assume they're congruent. Same thing with angle measures. Same thing with size of angles. So look over here in our things we can't assume. You can't assume that 2 lines are parallel, even if they look parallel, unless they're marked, okay? So if I just draw 2 lines like this, you can't assume that they're parallel until I put the marking for parallel on them. And we'll talk about the marking for parallel tomorrow, actually. Exact angle measurements. So you can't look at an angle and say, oh, I think that looks like it's about 72 degrees. Like the picture you just saw was very clearly not 98 degrees. Things are not drawn to scale in geometry a lot of the time, okay? And then you can't assume that things are equal or things are congruent without them being marked. So even if I draw 2 angles that look an awful lot alike, unless I mark them, you can't assume that they're congruent. It could be that one is like 72 and one is like 71, okay? So just to sort of lay out those guidelines as we're jumping into the real meaty geometry stuff, just be careful about what assumptions you're taking from a picture. And remember this rule. This is my favorite rule ever. If I mark it, you have to believe me. And if I don't mark it, you can't believe it, okay? The next couple of slides are really just words. I think you've got some pictures to draw in there, but most of these we've talked about. So like acute, right, and obtuse. You know those, right? Acute angles, right angles, obtuse angles. Draw yourself some pictures. Notice the right angle has that corner marking. I don't know if you've talked about a straight angle before. Jackson, you have something to add?
No.
Okay. A straight angle is an angle that measures 180 degrees. If it measures 180, what is it really?
Line.
It's a line. A straight angle is just a line. Okay? But we can call it a straight angle. Now, you can also have something called a reflex angle. A reflex angle is more than 180. Okay? So that's where you start here and then flip open more than 180 degrees. So technically this is like a regular angle measure, but this would be a reflex angle, kind of on the outside. Kayla?
Basically with that, if you put like say on a cube, if there's like a circle on the outside, then it's
Yep.
a reflect.
If I measured this angle, you're right, that would be a reflex angle. Yeah, good point. Good point. Questions on any of those? You okay with all those pictures? Again, I left the definitions in there for you because we've sort of already talked about these. Complementary and supplementary. These are going to be important because you're going to see problems that say something like such and such angles are complementary. Right away off the top of your head you should be going, oh, then I know they add up to 90. And supplementary, they add up to 180. Okay. So again, you can't just say one angle is complementary. Like I can't hand you a single angle and say this is complementary. Complementary is a pair of angles. Okay? Questions on those? Can I move on? Okay, these ones I want to make sure that we reiterate. Adjacent angles. What does adjacent mean? Next to, that's right. So adjacent angles are next to each other, and they share a vertex in one side. So like angles 1 and 2 here are adjacent angles. See how they're right next to each other and they have this side that they share in common? Okay, those are adjacent. A linear pair. We had a lot of trouble with this on the vocab quiz. A linear pair are adjacent angles. So again, they're angles that are right next to each other. But they still share that side in common, but the other sides make a straight angle, which means they make a straight line. Now, if they make a straight line, what do you know about them? They must add up to 180, yeah. So anytime you have a linear pair, you know that they are supplementary and they add up to 180 degrees. And then vertical angles. Vertical angles are angles that are formed when you have two intersecting lines. It's the angles that are across from each other. So like angles 2 and 4 are vertical angles, okay? And also angles 1 and 3 are vertical angles. Okay? So vertical angles aren't adjacent. They are not adjacent. They are across from each other. They still share a point in common in the middle, but they don't share that side. Okay? Questions on those at all? An angle is 1/4 the measure of its supplement. Okay. So we have two things that we're talking about here. We have an angle. And we have its supplement. Let's talk about that word supplement for a minute. What does that sound like to you? Supplementary, yeah. So a supplement to an angle is like its partner that would make it supplementary. So if I had a 30-degree angle, what would the supplement be? 150, because that's what it would take to make 180, right? So what would a 100 degrees angle supplement be? 80. Okay, So that's what I mean by supplement, is it's the other angle that would make it 180 degrees. So I don't know the measure of my angle. What do we use in math when we don't know something? Think algebra. What do we use when we don't know something? We use x, right? So I'm going to call my angle x. Okay? So then what would the supplement be? Let's think about how we were getting those numbers a second ago. When I said 30, you said 150. When I said 100, you said 80. How are you getting your answers, Rachel?
180 minus x.
Okay, you were taking 180 and subtracting the number I was giving you, right? So if our angle is x, our supplement is going to be 180 minus whatever x is. Okay, so if the angle is x, then the supplement is 180 minus x. Now let's go back to what the problem says. An angle, I'm going to go kind of word for word here. Actually, I'm going to slide this down so I can go right up above it. So what are we calling our angle? X is, that's our equals sign. You're going to cover that a lot more in algebra, but when you're setting up word problems, quite often the word is where your equal sign goes. An angle is 1/4 the measure of its supplement, which is 180 minus x. Do you see that equation kind of making itself up there? We know that our angle is 1/4 of the supplement. So that's how I'm going to set this up. I know that's a scary looking equation. I'm actually going to recopy it down here so we have some room to solve it. So, whoops. X equals 1/4 180 minus x. Okay, there's a couple of different ways you could solve this. I'm going to show you a way that I like to use when it comes to fractions. Okay, because fractions freak me out, and if they freak you out, it's okay. What could I multiply 1/4 by that would get rid of it? Caitlin? I heard it over here. Matt, was that you?
Yeah,
4, yeah. Because 4 times 1/4 makes 1, right? 4 is really the reciprocal of 1/4. That means I would also multiply this by 4. Okay. So now I have 4x equals, and over here this is gone, and now I just have 180 minus x. How do you want to solve from here? Go ahead, Matt.
add 1x to each
Yep.
side.
Yeah, this is a minus 1x, so I would add 1x to each side, plus x plus x. And I get 5x equals 180. And then let's divide by 5. And I get x equals, let's see, 5 into 18 would be 36, I think. Anyone have a calculator out there? You can double check for me. I think it's 36.
36.
Is it 36? Great. Okay. What does that mean? What did I just find? The angle, the original angle I was trying to find, right? So that means my angle, if I look back over here, is 36 degrees. What would the supplement be? 180 minus 36. 144? Okay. Is it true that 36 is 1/4 of 144? Take 144 and divide it by 4. And let's see if we get 36. We should. Okay, so yep, that's true. So I would make sure that you have that example copied down. Make sure you have everything copied down that I did. And that way when you hit that one in your homework assignment tonight, you can check back to this example. Okay, if you're feeling like, oh my gosh, I never would have been able to do that on my own, I don't expect you to yet. Okay, so practice with mine first. Okay, let's look at example 2. It says, suppose angle 1 and angle 2 are supplementary and adjacent, with angle 1 being 60 degrees. What would my diagram for this look like? How are they supplementary and adjacent? Jake?
Well, they would share the, so you just draw like, I can't really explain it. Like, just draw an
Do you want to
angle.
come up and draw it?
Not really.
Okay. Someone want to come up and draw it? You can. Matt, you want to try? I'll even hand deliver it to you. You want to give it a shot? Let's see what you do. And just draw it right down there.
And it just be
You got it.
60 degrees like that.
That's it. Yeah.
Angle one.
I would've gotten it.
You would have gotten it wrong? Okay. First of all, supplementary means they need to add up to 180, right? So here's my 180 degrees. And for them to be adjacent, they've got to share these two lines. So this one's 60. We've got this angle over here, and total they make 180. So supplementary and adjacent. What's the other word for that? Linear pair. Good. This is a linear pair. How would I find measure of angle 2? Jackson, go ahead.
You would subtract 60 from 180.
Yeah. If total they have to make 180, I could do 180 minus 60, and I find 120. You got it. Questions on that? Olivia, you writing all this down?
Yeah.
Okay. Okay, if angle 1 is 43, so this is really similar to that last question. If angle 1 is 43 degrees, how would I get the measure of angle 2? Even if you don't know the answer, Preston, tell me how to do it.
You do 180 minus 43
And how did you know 180?
because it's a straight line.
Okay, so the two angles together make a straight line, right? So that's how I know it's 180 degrees. I would do 180 minus 43, which I think is 137. And that means angle 2 would be 137 degrees. Okay, if I call angle 1 x, what would I know about angle 2? Caleb?
It's 137.
Well, okay, this is like a new question, so it's
Oh.
not referring back to that old one. Olivia, you think no?
No.
Give it a shot. What were you going to say?
Never mind.
No? Okay. Hunter, what do you think?
Would angle 2 be 43?
Okay,
It's a different problem.
we're not using these at all. Okay? We're going to like a whole new, so now I'm saying angle 1 is we're just going to call x. What would angle 2 be called? Go ahead, Jackson.
180 minus x.
Yeah, you would do 180 minus x. And that's how you would have to leave it because you don't know what x is. So you would just say 180 minus x would be angle 2. Okay? Those are confusing when they give you one picture and like lots of different numbers. Remember that each one of those kind of starts over. And then, all right, find as many measures as you can in the picture below. Preston, what do you think?
You make angle 2 62 degrees because it's across the way, and then
Okay, actually I want you to hold that thought for a minute. You are right, because I taught that to you prematurely. Pretend you didn't know that yet. Okay? Pretend you didn't know that the one across from it would be 62. Let's start somewhere else. Rachel, what do you think?
And you would have to do 180 minus 62 to find 1 because it's 180 line.
Yep, so we've got a straight line right here, right? So we could do 180 minus 62 for angle 1, which is going to be 118, is that right?
Yes.
Okay, someone tell me something else now you could figure out. Jackson?
If that one's 118, then you know the angle 2 is 62
How?
because you subtract 118 from 180.
Okay, so look, I've got another straight line right here, right? So if I know that this one is 118, then I should be able to do 180 minus 118. And that's going to be 62. Which is actually how we prove what Preston said.
and then
Okay? And then you got the other one?
yeah, and then you add the 62s together, which is 124. Then you subtract them from 360.
Okay.
And then
That would almost
divide
work.
that by
Oh, okay. Okay, so Preston's saying we could add these two together, subtract from 360. Where on earth is he getting 360 from?
Oh,
Caleb?
Because all of them together will make 360.
Okay, when I go all the way around, that would be 360. And then you divide by 2, which would give you these two, right? So you would have 118 here and something else here. But I'm gonna go easier than that. You are absolutely right, that would work, but what's another thing we could do to get this angle over here? Okay, Caleb.
You can minus all of them from.
Okay, so from 360, you're thinking? So we could say, all right, we know the whole thing's 360, subtract this, this, and this from 360? Easier than that even. Matt, what do you think?
Just minus 62 from 180.
Okay, so I've got this blue line that I started with over here, right? Still 180. So now I know 2 and 3 have to make 180. And 2 is 62, so I could do 180 minus 62 again, right? All those other things that you guys said would have worked just fine. But sometimes some of us work too hard. Sorry, that's kind of hard to see, but that's a 118 in there. And that right there, do you see that you end up with 62 and 62 and then 118, 118? Yeah. So that really is a proof of the vertical angle theorem. That's not really technically a proof. For a proof, you would have to show that it always works.
That's an instant.
But it is an instance, yes. And if you used more generic, like you didn't use actual numbers, if you just talked about the angles, you could use that same method to prove it. Questions on any of that? Okay.